So I wanted to create a video to talk through lecture question 1 from week 2 because a lot of people had trouble with it. So the idea of this problem is you've got this kind of random graph. Suppose this is the graph of some function y equals f of x. So this would be some kind of piecewise function. But let's just accept that this is the parent graph for some basic function. So these are the points on the graph of y equals f of x. We're supposed to use that to sketch the graph of some related equations. In this case, so suppose you have that same parent function where it's named f in this problem, but this time inside of that parent function you have x plus 2 instead of just x, and outside of the function you have a minus 3. So the idea here is to first identify what transformations are related, or what is the effect of this plus 2. So if you add 2 inside of the function f, that's going to shift all of the points. Well, it's a horizontal shift when it's inside. And horizontal shifts, think of it as they do the opposite of what you kind of expect them to do. So plus 2 actually goes left. It goes back 2. So the effect of this plus 2 is to shift all of those points left 2 units. And the minus 3, so this is outside of the function, the result of this minus 3 is going to be a vertical shift. Vertical shifts do just what you expect them to do, so minus 3 will shift the points down 3. So that's the idea of this problem, is to first look at the equation and look at what transformations would be needed. So if I've already graphed the parent function, then for this equation I should shift all the points left 2 and down 3. According to this equation. So you would go point by point, take this point, take each of these kind of corner points and shift them according to that equation. So left 2 and down 1, 2, 3. So the point would land down here. And then take this point, go left 2 and down 1, 2, 3. So that's going to land right here. And then I'll go ahead and connect those dots. So this line here is this portion of the graph shifted left 2, down 3. You land here. Take this point, go left 2 units and down 3. 1, 2, 3. It lands right here. Connect those dots, and that's this section of the graph shifted left 2, down 3. And then last, I'm going to move this endpoint. So if I go, I need to look at it here, left 2 and down 1. I'm kind of getting off track here. Down 1. 1, 2, I guess I didn't quite have enough lines here. 3. Yikes. Okay, pretend that's a straight line. But so that would be this portion of the graph shifted left 2, down 3. So this would be the result right here. So this in blue is the graph corresponding to A. And there might be noise in a minute, just a second. Now, for the second equation, should use my headset, but now the kids just walked in the house, so pardon any background noise here. According to the second equation, okay, so we have to think about what transformations. If you have negative 2 times your function, then what's going to happen is the negative will cause the graph to be reflected across the x-axis. The times 2 is going to be a vertical stretch. Because it's times 2, that's a vertical stretch, as opposed to if it was plus 2, or minus 2, that would be a shift up or down. But so you can kind of make these two things happen at once by multiplying the y coordinates. Multiply the y coordinates by negative 2. Now also you have a minus 1 inside of the parentheses, so that's a horizontal shift because it's inside. Horizontal shifts do the opposite of what you think. So minus 1 is actually going to go forward 1, goes right 1. So this causes the graph to be shifted right 1. Okay, so if we do that to the points, here's the starting graph in black. Oops, I erased part of it. Take this point right here. The y-coordinate is 0. So if I multiply by negative 2, it's still 0. And shift it right 1. So it lands here. Okay, take this point. Technically, I should do the horizontal shift first. So I'll move it right 1. And then the y-coordinate here is positive 2. So if I multiply it by negative 2, like I'm supposed to, because of this negative 2 out here, so 2 times negative 2 gives me negative 4. So 1, 2, 3, 4, it's shifted here. Okay, and I'm going to connect those dots. There. Okay, so that's this section of the graph reflected across the x-axis and then stretched out by a factor of 2. This point, so if I go right 1, the y-coordinate is positive 2, so if I multiply by negative 2, that gives me negative 4. Keep the same x, I'm trying to line it up, so I get that line there. Last point, so this is negative 2 right now, I believe, on the original graph. Multiply it by negative 2, now it's positive 4. I'm going to kind of run into my f of x here. Positive 4 up here, and then connect those dots. So the graph in red there is the final graph. If you take this whole graph that's in black, flip it over the x-axis and stretch it by a factor of 2, shift right 1, you get what I drew here in red.